setup for a device known as the Wheatstone bridge. It's discussed in your PowerPoint before you got to this point. So we come out of the power supply, we don't need much voltage. And we come over here to what we call the slide wire, which is connected here and here. So it's 100 centimeters in between. This would constitute length 3 and length 4, depending on where we happen to put this little wire from the galvanometer. Now, from this point here, it goes back into the power supply, so that's a complete circuit. So we're going to set this up with a decade box over here and the spools over here. So what we're measuring is R1. The decade box would be R2. This is 1930s technology on measuring resistance. Now this is a slightly newer one here out of China, about $8. But before you do anything with any kind of decade box, you want to compare it against what your multimeter says all the settings are. Because it's really easy for a student to actually burn out the resistors in a decade box, and you wouldn't know it from looking at the front. You'd only know it if you tore the box apart. And a lot of these, they're totally sealed, so you can't take them apart. You can use a partially destroyed decade box as long as you know where the bad parts are, and you just put an extensive label on the side, because we know we don't have much money these days. Okay, so this point here, where the decade box is connected, which is our known resistance, the galvanometer, which will see zero current when we have everything in balance, is also connected to this wire by a wire to this nice steel conductor here, and so is our spools. So essentially, they're at the same voltage point. We then have the spools also connected to the zero end here, and we have the decade box connected to the 100 point. So essentially, when it's in a perfect condition, those are in parallel, because no current would be flowing through the galvanometer. Now, what I'm going to do is stop the video, and I'm going to turn down the lights and focus on the galvanometer. I'm going to touch over here at 30, I'm going to touch at 70, it'll deflect one way for 30, another way for 70. When I get it perfectly imbalanced, it will have no deflection over here, and the distance from 0 to that point would be length 3. 100 minus length 3 would be length 4.